In this example, we're asked to find the limit as x approaches negative infinity of the square root of 2x squared plus 5 over 3x minus 1. And I see this square root could look a little better than it did. Okay, that's a little clearer. So the first thing to notice about this is that the form of this limit, if we allow x to approach negative infinity, well, you're going to take your negative 100,000, let's say, and square it. So it's going to be a positive value here. 2x squared plus 5, you're going to end up with a very large positive value in the numerator. So we put infinity there. And then 3 times your negative 100,000 or whatever, as x approaches negative infinity, you're going to have a very large negative value in the denominator. And the form infinity over infinity is an indeterminate form. So we need to rewrite this limit somehow in order to evaluate it. Since this is not a rational function, because of the square root, it's not a rational function, then our strategy for resolving this indeterminate form, infinity over infinity, is to divide the numerator and the denominator by the highest power of x in the denominator. So the strategy is going to be to divide the numerator and the denominator by highest power of x in the denominator, which is x, which normally, because we're going to be dealing with a radical in the numerator, I want to write this in an equivalent form. So we could say x is equal to the square root of x squared. It'd be tempting to say that's true. The problem is, if x is negative, which since we have x approaching negative infinity, we can certainly assume x is negative, well then this quantity right here is negative, but this is going to give you a positive value. If you take that negative x and square it, and then take the square root, you're going to end up with a positive value here. So in order for these to be equal to one another, if x is a negative number, is just to put a negative in front here. And that'll actually work. When you do the square root of x squared, you're going to end up with x, except we'll have turned it positive when we squared it and then took a square root. So we just need to make it negative again. So the negative in front will do that. So for a negative value of x, x is equal to negative square root of x squared. I want to make that note right here. That way, when we divide in the numerator and denominator, I'm free to write this as x or as the square root of negative x squared, since they're equal to one another. And by the way, if you want to convince yourself, like, I don't really buy that this is true, plug in, say x equals negative 3. Substitute negative 3 for x. You get negative 3 here. When you square negative 3, you get positive 9. Take the square root, you get positive 3. Slap a negative in front, now it's negative 3 again. So the two sides are equal to one another. Okay, so I'm going to divide that in the numerator and the denominator. I'm going to use whichever form of this expression is more convenient. So like in the denominator, I see 3x minus 1. I'm going to divide it by x, because that's what looks like what I already have in the denominator. In the numerator, you have the square root of 2x squared plus 5. So in the numerator, I'm going to write it as negative square root of x squared. I am dividing by the same quantity on the top and bottom, so I'm not changing the overall quantity when I do this. So the advantage of being flexible there is you can divide both parts here by x. So 3x divided by x, that's 3, minus 1 divided by x. So when we divide the numerator, the reason I wrote it as a square root is because now we can pull that negative out front and then write this as one big square root expression. So 2x squared plus 5 over x squared. All under that square root. And then in the next step, I'm going to divide both parts. So the same way here I divided both parts by x, now I'm going to divide both parts of this expression in the numerator by x squared. Let me get rid of this. So this is equal to the limit as x approaches negative infinity of negative square root of 2x squared divided by x squared, so that's just 2, plus 5 divided by x squared. So you're allowed to take your numerator and divide each part individually by this denominator. This is fine. Now, this is the part that's more fun, I think. So as x approaches negative infinity, as x approaches positive or negative infinity, things like 1 over x approach 0. Because you have 1 over some huge negative number, 1 over negative 100,000. So that's negative 1/100,000. That's very, very small. So essentially 0. Same deal here with 5 over x squared. 5 over negative 100,000 squared, that 5, over some huge number, that's essentially 0. And so the 5 over x squared, the 1 over x both go to 0. And so what we're left with is just negative square root of 2 over 3. And that's the value of the limit. The key here is the indeterminate. We want to resolve the indeterminate form, negative infinity over infinity, by dividing top and bottom by highest power of x in the denominator, and knowing how to take that x and write it in a form that will be easy to reduce with the square root in the numerator. In this case, it was that whole discussion about how for a negative value of x, x is equal to negative square root of x squared. And for the record, if x were positive, then x is equal to positive square root of x squared when x is positive. So we divide top and bottom by that highest power, break it up and simplify. Limits of the form, finite number over plus or minus infinity go to 0, and then you're left with a finite value.